Okay, today we're going to talk a little bit about smell. As we can see here, we have a nose, or at least my attempt to draw a nose. And so when we smell something, it actually all mostly works up here on the top part of our nose, closer to the brain. And we have these little neurons with their dendrites. And right here we have an up close look at those dendrites. So most these dendrites receive chemical signals that are sent up here into the olfactory bulb and then to the brain. So if something were to happen to, like, let's say this part right here, like in a car accident, sometimes what happens is this bone right here gets broken, and we're not able to smell. Even though it feels broken because it can regenerate in about a couple months.
When that plate, like these places, it destroys the neurons,
Yes.
and then it will recover.
Yeah.
Mm-hmm.
This plate here will destroy the neurons, and they'll regenerate in a couple months. An example of that is with COVID. Even though the neurons here get degraded, they can regenerate after a couple months and that. So let's take a look at the dendrites. So here in the dendrites we have good old G protein coupling receptors that we are used to seeing a lot. We have a new enzyme known as adenylyl cyclase, and then we have a couple channels here. We have a ligand-gated non-specific channel. We have a voltage-gated sodium and a voltage-gated chlorine channel.
Yes, ligand non-specific cation channel.
Yeah, it's a non-specific ligand cation channel. So, yeah. So what happens how does it start? Well, G protein coupling receptors, when they receive a signal that we're feeling like a smell, they come and they activate the adenylyl cyclase. And what the adenylyl cyclase enzyme does is it sends here a signal to synthesize something known as cyclic AMP, or CMP, AMP for short. And this comes here to the ligand-gated channel and it opens it up. So what happens when it's opened? When it's opened, calcium comes in, and calcium depolarizes the cell, sends out a Wang or a sphere of influence into the cell, and that opens the voltage-gated sodium channel, allowing sodium to come on in, and it causes chlorine here to leave the cell, and this sends out an active potential signal up into the olfactory bulb and into the brain.
What is the structure handle like that? Well, what do we call?
What we call this? The dendrites.
Dendrites, okay. When you compare to the process of taste compared to smell,
Yes.
can you find why we have a very strong memory having smell together? We have smell has the most strong memory, right?
Yes.
Gives strong memory. Can you see why those
Yes.
compared to taste?
Is because we have an olfactory bulb here.
Directly connect to the
brain.
brain. That's
Yes.
why we have a strong memory. We have strong memory, something related with smell.
Yes.
Yes. Is there anything that you want to teach?
Smell does not use epithelium cells, unlike taste, and I think that's it. Thank you.